Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today's topic is a problem which is based on periodic signals. Now, in a current example, I have placed a function or a signal which is a sinusoidal, but it is not a complete sinusoidal. This sinusoidal wave is only available for a half period, and for next half period the amplitude is 0, or you can say that the graph is having only a positive sine wave and negative sine wave is absent, and this is continuous till infinity, and we have to find out a Laplace transform of such type of waveform. So first of all, go through the question first. Now look at here, a problem 4. We have to find out the Laplace transform of this wave. Now look at here, in this wave only positive peak of sine wave is given, and in negative peak the amplitude of the negative peak is 0, or you can say the negative peak is absent, and again you have a positive peak. Now look at here, the function or this signal is continuous throughout the time period, and in between 0 to 2 pi, this is the time period of this function or a sine wave. Now in this whole period 0 to pi carrying a positive wave or positive amplitude of sine wave, whereas from pi to 2 pi the amplitude is absent, and we have to find out the Laplace transform of such type of signal. So first of all, we'll plot the function, we'll write the equation of this question. So before moving to solution, first of all you should know that in case of a Laplace transform periodic wave, we have to find out the Laplace transform of first period only. Reason is the graph repeats itself after a particular time period, or you can say that here in this graph or in this question the graph completes its cycle at the 2 pi, and again it starts its new cycle from 2 pi and it will complete or it will move on till 4 pi, which means this sine wave produces a same value in between 0 to 2 pi, and again he repeats itself from 2 pi to 4 pi, which means this graph is a periodic signal. Now in this case function repeats itself after a 2 pi, which means if we find out the Laplace transform of first period, then the same Laplace transform will be carried out till the towards the infinity, or you can say that the same Laplace transform result will be there from 0 to 2 pi, from 2 pi to 4 pi, and so on. So it is not necessary to find out the Laplace transform of this periodic signal till infinity, only first period is enough. So first of all we will write its formula, and before of that we'll find out the equation of this x of t. Now this was the graph, and as I told you earlier, we have to find out the Laplace transform of only a first period. So let's say the first period x of t, in x of t the first period function is represented by, I'm going to represent it by x1 of t, and in between 0 to 2 pi, which is a total complete period. In this complete period this function produces two different outputs. Basically it's a sine wave, but the sine wave is there only for half period, and in next half period the sine wave is absent. So we are going to represent this whole thing in equation format. So look at here, here the amplitude is a and the graph is sinusoidal, so I am going to write here a sine t. Why I have written t? Because on time axis the t is mentioned. If omega t is mentioned, then I am going to write here a sine omega t. Now next part, this function is available from 0 to pi, so I am going to write here 0 to pi, and from pi to 2 pi the amplitude of this function is 0. So what I am going to write here, the amplitude is 0 from pi to 2 pi. And what we are going to do, we are going to find out the Laplace transform of x1 of t. Reason is, according to statement, we have to find out a Laplace transform of first period only. So first of all, what is the statement of Laplace transform of periodic signal property? A Laplace transform of continuous periodic signal is represented by x of s, where the property statement is 0 to t Laplace transform of first period, and the function is represented by, in this question the function is represented by x1 of t, and according to definition this input is multiplied by e to the power minus st dt and whole divided by 1 minus e to the power minus st. Now look at here, as this x1 of t is the definition, or you can say that x1 of t is multiplied by e to the power minus st, and this product is integrated over the range from 0 to t. So you can say that this is nothing but the definition of Laplace transform, and as this is the definition of Laplace transform, we are going to represent this x1 of t by x1 of s, and the denominator part remains as it is, e to the power minus s into t. So before calculating the Laplace transform of x1 of t, first of all we should know the total time period. Now in this graph the total time period is known. The total time period starts from 0, basically it is started from 0, and this wave terminates at 2 pi, which means the total time period of this such type of graph is 2 pi. Now we'll find out the solution of this function. First of all we will calculate a Laplace transform of x1 of t. Now a Laplace transform of x1 of t. According to definition of a Laplace transform of x1 of t is represented by x1 of s, and the definition is we have to integrate this x1 of t over the range from 0 to t, and the function is x1 of t, which is multiplied by e to the power minus st dt. But x1 of t is having two different values. So according to that, this integration limit will also changes into two parts. Therefore x1 of s is now in between 0 to pi. x1 of t is having input function is a into sine t, and the rest of the part is e to the power minus st dt, plus in second part, that is from pi to 2 pi, this x1 of t is having amplitude 0. This thing we have discussed just a little bit earlier. Why the x of t is having amplitude a into sine t in the region 0 to pi, as well as pi to 2 pi the amplitude of x of t is x1 of t is 0, that we have discussed earlier, into e to the power minus st dt. So look at here, as the e to the power minus st is multiplied by 0, which means this whole part result is 0, so we have to concentrate on only a 0 to pi function, or you can say this integration. Now look at here, the a is constant, and we can write sine t. We know that formula, a complex formula. Sine t is e to the power jt minus e to the power minus jt whole divided by 2j, and a is constant. So I'll take a outside from this integration and I'll replace this sine t by its formula. So what is our next step is x1 of s is a I have taken common, and 0 to pi is our integration limit, and this sine t is replaced by its formula e to the power jt minus e to the power minus jt whole divided by 2j into your e to the power minus st dt. Now I'll take 2j outside and I'll multiply e to the power minus st inside this bracket, and according to linearity property we can integrate products separately. How? I'll show you. Now x1 of s, as I told you, I am going to take 2j common because it's a constant, so a by 2j, and in integration we have a product e to the power jt is multiplied by e to the power minus st minus, in other bracket we have e to the power minus jt into e to the power minus st, and this whole part is going to be integrated with respect to time t. Now according to linearity property, if we have minus sign in between two functions, then we can split this integration, or you can say we can apply Laplace transform both the sides separately. So The next part is a upon 2j. We are going to apply integration limits on both the parts separately. So this is going to be 0 to pi e to the power jt into e to the power minus st dt minus, this is our first part, and in next part what I am going to write, again 0 to pi e to the power minus jt e to the power minus st dt. This is our second part. Now here the bases are same, so we can add the powers, but before adding I am going to take minus t common from this numerator. So what you will get, 0 to pi, as I told you bases are same, then orders will get added, but after adding what I am going to take, I am going to take a minus t common, so this will be minus t into bracket s minus j dt. This will be our first integration. A minus in second integration, what you will get, 0 to pi. Here also I am going to take minus t common, so this in this bracket what you will get, s plus j. We have s plus j inside this bracket, and I am going to integrate this function with respect to time t. Now we know that the integration of exponential function is always exponential, but it is divided by a constant part which is present in the power, in its power. So the constant part which is present in its power is minus of s minus j, and in second part we have minus of s plus j. So this part will be divided, or we can say that it will be in denominator after taking integration of exponential function. So what you will get, the exponential function integration is similar, exponential e to the power minus t s minus j, but as I told you the constant part, which one is a constant part? Here the integration total depends on time t, so t is the variable, whereas minus of s minus j is the constant part, so that will be in the denominator. Our integration limit is 0 to pi minus, again here also after taking integration minus of s plus j will be in denominator. Now I'll substitute the limits in both the parts. Now the upper limit was pi and lower limit was 0. So our t is replaced by first of all pi, and then minus I am going to substitute a lower limit. So in denominator we have that function minus of s minus j, and the t which is present in the power of exponential will be replaced by the upper limit and lower limit one by one. So upper limit was pi, so e to the power, what I am going to write, minus pi inside the bracket I am going to write s minus j minus, now we will substitute the lower limit which is 0. Now this place was replaced by 0, so power of exponential term will be 0, and we know that e to the power 0 is always 1, that I will substitute later on, minus, in another bracket we have upper limit is again pi, so e to the power minus pi, but inside we have s plus j, minus the lower limit was 0, so e to the power 0, and whole divided by minus of s plus j. Now I'll substitute the limits, e to the power 0, e to the power 0 is 1, and I'm going to split the powers of exponential function. How? I'll show you. So just multiply this pi inside this bracket and split these orders. So what you will get, e to the power minus pi s into e to the power minus minus become plus, so we have e to the power plus j pi minus 1 upon minus of s minus j. This is our first part, and in second part what we have, again this minus will be multiplied inside this bracket, so we have e to the power minus pi s into e to the power minus into plus, answer is minus pi j, or you can say j pi, minus of 1 whole divided by minus of s plus j. Now my suggestion is just multiply numerator and denominator by minus sign, so that denominator minus sign will get cancelled. So look at here, a upon 2j. After multiplying minus sign in the numerator and the denominator, what you will get? This whole product becomes minus, but this minus one will become plus, and the denominator sign will get cancelled. So we have 1 minus e to the power minus pi s into e to the power j pi whole divided by s minus j, minus here also after multiplying minus sign, this one will be positive and this product will be having negative sign, and this minus sign will get cancelled. So we have 1 minus e to the power minus pi s into e to the power minus j pi whole divided by s plus j. Now what is next? What is the value of e to the power j pi? Now we know that we have studied one formula in mathematics. E to the power I theta is cos theta plus I sin theta. I am going to write here e to the power plus or minus j pi is cos of theta plus or minus j sin theta. Now here the theta value is pi. So we know that cos pi is minus 1, whereas sin n pi is always 0, which means you have a value only a minus 1, which means this j pi and this minus j pi will gives us a value which is minus 1. So what I am going to do, I am going to substitute a minus 1 where at this place. Here e to the power j pi and e to the power minus j pi will be replaced by minus 1, and this minus minus will give a plus sign in both the cases. So what you will get? 1 plus e to the power minus pi s whole divided by s minus j minus 1 minus pi s whole divided by s plus j. Now my suggestion is just simply multiply denominators in its numerator, or you can say just do the cross multiplications. Now I have just cross multiplied denominators in the with the numerators, and this is the result what I have got. Now we know that s minus j and s plus j, after multiplying the result, what you will get? S square plus 1 square, that is 1. And also I am going to multiply numerator part also. So after multiplying we have got this result. As the s is multiplied by 1, that's why I have written s. S into e to the power minus is this, j into 1 is j, and j into minus e to the power minus is this, and I have multiplied minus sign with this part first, and then I have multiplied with this. So s into 1 is s, but due to minus sign we will get minus here. Similarly with this one also. Now as we have minus j, so minus j into e to the power minus s is minus, but this minus will gives us a plus sign in both these j. Now next thing is, look at here, we have got some similar terms. As here we have s, so here we have minus s, so these two s will get cancelled. Similarly here we have s into e to the power minus s, here we also we have opposite term, so these two terms will also get cancelled. Now look at here, here we have plus j, here also we have plus j, so it will become twice of j, and these two terms are also similar, j e to the power minus s, j e to the power minus s. So what I am going to do, I am going to take a 2j common. I will show you how. Now look at here, from numerator you can take 2j common, and after taking 2j common, the resultant is your 2j and this 2j will get cancelled. So this 2j and this 2j will get cancelled, and the remaining part is our result. So after cancelling 2j, which is present in the denominator and numerator, you have got this result, and this is our x1 of s. Now we have to substitute this x1 of s in our x of s formula, that is a statement of Laplace transform periodic signal. And what was that? X of s is nothing but x1 is upon 1 minus e to the power minus st, where this t was my 2 pi and x1 of s value I have already calculated. So I'm just replacing this x1 of s by value this, and t is replaced by 2 pi. So my solution is now you can take this s square plus 1 in the denominator. And this is our result. So if in exams, if they give you a numerical or a question based on sinusoidal, then don't get confused. First of all, try to obtain the exponential equation or complex exponential form of that sine wave, and just do the multiplication with the e to the power st, and then after applying a Laplace transform, you will get this type of result. So don't get confused. Stick to your topic, stick to your basics. So we'll do this similar type of numericals in next future videos also. But for that, you have to stay tuned with Ekeeda and subscribe Ekeeda for further more videos. Thank you so much.